Hey guys, how's it going? So in this video, we're here to calculate the eigenvalues associated to this matrix A. And here I define the parameters. You probably see, if you've seen a 2 by 2 matrix, then you can probably skip this step. But pretty much, just to find the eigenvalues lambda, in this case, there'll be probably 3. We need to pretty much solve this this equation. In other words, we go find the determinant of the matrix A minus the constant lambda times identity matrix I, and we're going to get to that in a second. So let's just deduce this solution here. So A minus lambda I, let's see what that is really. So A minus lambda I, this equals this matrix minus identity matrix. If we recall, the identity is just a series of 1 across the diagonals with 0 everywhere else. And we're going to be multiplying this by lambda. So if you multiply this by lambda, everything times lambda would just be lambda, lambda, lambda. Well, lambda times 0 is 0. So technically, we're just doing this A minus this matrix here. So technically, 4 take away lambda would be 4 minus lambda, minus 10 minus 0 is 0, and so on. So ultimately, we're going to have, I'll do it quickly, 4 minus lambda here, 6 minus lambda here, and 6 minus lambda here, and the rest of it is going to be the same as A. 0, 0, minus 2. Okay, now we need to find the determinant of this part. So determinant, how do we do this? Well, what we do is that we multiply across the diagonals on each side. So this plus these minus the other side. So these 3 minus these 3 minus these 3. So you have to kind of, it's best to draw like a line. So if it cuts off here, you're over here. If it cuts off here, you're on these 2, and so on. So we'll have a try anyway. So what we're gonna get? We're gonna get 4 minus lambda times this, which is 4 minus lambda, 6 minus lambda squared, plus this times 0, which is 0. 10 times 0 times minus 2 is again 0. So it's the first part minus the sum of the opposite side. So 10 times times this term times 0 is 0, times another 0, 4 minus lambda times minus 2 minus 2. So this is the only thing left. This times this times this. So what's this? Minus 2 times 2 is plus 4. 4 times 4 minus, well, let's just write the whole thing out. And that's it. So now we need to somehow simplify this equation. Okay, so let me just quickly rub out the top information since we don't need it. Okay, so trust me guys, this is a lot easier than it seems. A lot easier than it seems. Okay, so back up here. Let's step this up. So what do we have? Let's collect the like terms here. So 4 minus lambda times 6 minus lambda squared minus this amount. We have basically determinant equals 4 minus lambda, 6 minus lambda squared, minus 4 minus lambda. And all of this, remember, equals 0, since these are the non-trivial solutions that equal to 0. Okay, so what do we have now? So, oh my god, this is so long. Okay, so we're going to have 4 minus lambda here. Let's try and factorize this. So they both have 4 minus lambda. We can factorize them out. So we're going to have 6 minus lambda squared here minus 4. And this equals 0. So what do we have so far? So we know the first pair solution, this equals 0. And now this part, 4 minus lambda. So let's factorize, open this up. So if you're not the square component, you're going to get 36 minus 12 lambda plus lambda squared. I'm just going to assume you guys know how to do this already. And then we're going to have 4 minus lambda here. Collect terms, 36 to 4 is 32. 32 minus 12 lambda plus lambda squared equals 0. Oh boy, now you go factorize this back in. So, okay, first thing, so we know the solution here is 4. So 4 times, I got it. 2 numbers are multiplied to get 32, 4 and 8, and then minus lambda here. Since we know 4 minus 8 is minus 12. And there we have it. So we have our